Okay, here I'm out at the park, Balboa Park. Library has been closed because of the coronavirus. So let's see how we can do here. Hopefully my recording will come through pretty quickly. I'll speak a little louder. We're at K61. Take a look at this. Right here. And we're looking from the top of the page. We're going through radiometric dating and the intellectual dishonesty of the evolutionists who pick and choose and then manipulate the findings using these scientific methods with presumptions that things were the same as they appear today in terms of radioactive decay rates and so on. Evidently not. Catastrophism changed that dramatically. And here we are now looking at the amount of meteoritic dust which points to a young Earth. One of these lines of evidence of a recent Earth is derived from the study of meteorites and comets, another way of measuring age, of which there are large numbers in our solar system. A tremendous amount of meteoritic material falls each year on Earth. Estimates vary widely, but the most careful studies have been made by Hans Petersen of the Swedish Oceanographic Institute. Petersen calculated that the total quantity of dust of meteor origin in the atmosphere up to a height of 60 miles amounts to about 28.6 million tons. Half the total, 14.3 million tons of such dust settles to the Earth each year, and 14.3 million tons of new dust must then enter the atmosphere. Isaac Asimov wrote an article, 14 million tons of dust per year, in Science Digest a while back. Petersen confirms this. He says, if meteoritic dust descended at the same rate as the dust created by the explosion of the Indonesian volcano Krakatoa in 1883, then Isaac Asimov says, my data indicate that the amount of meteoritic dust landing on the Earth every year is 14 million tons. Hans Petersen, in another article, says the significance of this large amount of meteoritic dust in terms of the supposed great age of the Earth is noted by Asimov as follows. Of course, this goes on year after year, and the Earth has been in existence as a solid body for a good time, for perhaps as long as 5 billion years. If, through all that time, meteor dust has settled to the Earth at the same rate it does today, then by now, if it were undisturbed, it would form a layer 54 feet thick all over the surface of the Earth. Obviously, no layer of meteoritic dust of any appreciable thickness, certainly not 54 feet, is found around the Earth's surface, although some indications of such a layer have been found on the ocean bottoms, but not 54 feet thick. Petersen and Rutschy have found good evidence from the peculiar nickel content of deep-sea deposits, both in the Atlantic and the Pacific Oceans, that several thousand tons per day of meteoritic dust are accumulated by the Earth. The absence of this meteoritic dust, F.L. Whipple says, on the Earth's surface cannot be reasonably accounted for in terms of crustal mixing processes, as Asimov claims. He projects that this happened even though he doesn't have evidence that it did. This type of material is composed mostly of iron with large amounts of nickel and other relatively rare components of the Earth's crust, and these elements are not found in sufficient abundance to correspond to the amount supposedly accreted by meteoritic showers over 5 billion years. For example, the average nickel content of meteorites is of the order of 2.5%, whereas nickel constitutes only about 0.0008% of the rocks of the Earth's crust. So much for that. Petersen goes on to say, thus about 312 times as much nickel per unit volume occurs in meteorites as in the Earth's crust. This means that the 54-foot thickness of meteoritic dust would have been dispersed through a crustal thickness of at least 312 by 54 feet, or more than 3 miles, they yield the present crustal nickel component percentage, even under the impossible assumption that there was no nickel in the crust to begin with. Lots of assumptions lead to false ideas. Similar calculations can be made for cobalt and other important constituents of meteorites, all testifying that there simply cannot have been meteoritic dust falling on the Earth at present rates throughout any 5 billion years of geologic time. Similar calculations indicate that enormous quantities of iron would have also accumulated on the surface, forming meteoritic matter during geological time. Iron is the most abundant element in the meteorites and is also abundant in the Earth's crust. Can this surface iron be not the Earth's original substance, but at least in significant part the accumulated meteoritic dust of ages? According to my calculations, he says, the dust would account for all the iron in the upper 1 mile, 1 plus or minus miles of the Earth's solid crust, which certainly accounts, too, for all the iron we've managed to dig up. The facts simply don't bear up these theories of a 5 billion year old Earth. But does anyone actually think that all the iron in the upper 1 plus or minus miles of crust was derived from meteoritic dust? Such a proposition seems out of reason on its face. Yet this is the strange conclusion to which we are led if meteoritic dust has been falling on the Earth for anything like 5 billion years. So we have conclusion there, and it's not substantially supportive enough of the evolutionist idea of how old the universe is. Now we have tektites, meteoritic glass. They'd also disprove evolution. The special type of glassy meteorites known as tektites is still more difficult to interpret. These are found in various localities in the form of what seems to have been showers of the particles. Seuss says there are only 1 million to 10 million years. Gerling and Yashchenko regard this as evidence against the cosmic origin for tektites. All these experts don't find the evidence to support their conclusion of a very old Earth. Radioactive methods for determining geological age. Nevertheless, Aaron says, as Stair in the summary of the evidence says, although some investigators believe that these glass bodies are of terrestrial origin, the preponderance of evidence seems to point to a cosmic source as the origin. Ralph Stair says, the significant feature about the relatively small ages indicated for the tektites is that they seem to be smaller than those of the same terrestrial strata in which they are deposited. Each of the major occurrences is thought to be one shower. Those in Czechoslovakia are weathering out of Miocene strata, but those in Texas, first described by the writer, are thought to be weathering out of Eocene strata, and those in Australia may be recent, and not conclusive in any one direction. Barnes says another significant fact, difficult to reconcile with uniformitarianism, is that the tektites are apparently not found in any strata earlier than Tertiary. Neither tektites nor other meteorites have been found in any of the ancient geological formations. Stair says then, this of course is hard to reconcile with the generally accepted uniformitarian concept that meteorites have been falling on the Earth at essentially present rates throughout some 5 billion years of geologic time. True meteorites, in fact, have apparently not been found in any but recent deposits. It is only the meteorites that escape decomposition and passage through the atmosphere that can possibly be recognized. There probably are many of these, and in the deep sea, where the rate of deposition is extremely slow, cosmic particles may be rated high in the sediments as compared to places where other sediments are abundant. No meteorites have ever been found in the geologic column. So much for that as a measurement of the age of anything. Now we have the amounts of helium in the atmosphere correspond also to a young Earth. Helium-4, another type of geophysical chronometer indicating an anomalously youthful age of the Earth, is the accumulation of radioactively derived gases in the atmosphere. The most important of these, of course, is radiogenic helium, which, as we have already pointed out, is derived from the disintegration of uranium and thorium in the Earth's crust. Some of this radiogenic helium, of course, escapes and eventually finds its way to the surface, where, if then added to the atmosphere. But it has been realized for many years that there's not nearly enough helium in the atmosphere to correspond to the supposed age of the Earth and the rate of escape of helium from the crustal rocks into the atmosphere. It may be reasonably supposed, therefore, that the entire atmospheric supply of helium-4 is of radioactive origin. Goldschmidt, considering the known helium content of the atmosphere and known concentration of uranium and thorium series in primary rocks, concludes that all the atmospheric helium would have been produced in the course of 2 billion years from 2 kilograms per square centimeter of primary rock. This represents about 1.3% of the total amount of primary rock that has been eroded and which therefore might have been expected to have delivered its helium to the atmosphere. So Hutchinson says, this implies that the true maximum age for the Earth on the basis of helium production would only be about 1/3% of 2 billion or 26 million years. And even this is impossibly high because it neglects any primary atmospheric helium, original helium, and any formerly higher radioactive decay rates, as well as helium that may have been making its way to the surface from non-denuded rocks. We just don't know because we weren't there since the beginning when the Earth was formed. The method used for avoiding this conclusion is to assume that the excess helium generated in the past has somehow attained the escape velocity, overcoming gravity and escaping from the atmosphere completely and into space. That's nonsense. This requires that the temperatures in the ecosphere, the outermost portion of the atmosphere, must be extremely high. Peterson, Lindemann, and others have shown that the amount of helium released from radioactive rocks during the geological life of the Earth exceeds the number now in the atmosphere. Assuming Stoney's mechanism to be responsible for the loss of helium that must have occurred, Spitzer deduced that the temperature at the critical level is either about 1800 degrees centigrade or, though usually less, is occasionally more, perhaps for 2% of the time is 2300 degrees centigrade. And even greater values may be required, for Maine has recently concluded that the amount of helium released and lost is far greater than has been supposed. Some theorists find the high temperature mentioned difficult to accept. All this is theoretical, no evidence to prove anything. Bates says no independent evidence of such high temperatures yet exists. In other words, instead of accepting the obvious conclusion from the helium content of the atmosphere that the Earth's age must be much less than usually believed, it is rather deduced that the ecosphere temperatures must be sufficiently high to permit helium to escape into space, regardless of how extreme this temperature may be. So Dr. Don Patton summarizes this. One very serious implication of erroneous conclusions of the age of the Earth by evolutionists is seen in the uranium-lead method, which decays known down to lead from uranium-238, and that's the method that's supposed to determine the age of the Earth. It produces as a byproduct helium-4, which is a relatively rare element in the Earth's atmosphere, and so we should be able to test rather accurately here what comes from radioactive decay. Lead, which they do measure, is very common, and so you have to guess how much lead was there to start with and how much was there from radioactivity decay, which is a guess. Helium-4, almost all of it would have come from radioactive decay because it's rare to start with and not like the lead. Well, you look in the rocks and you find it's not there. Yet laboratory tests indicate that it should be contained in the lattice work of the rocks for over 100 million years. But what is there would indicate that it's only a few thousand years old. Well, they know that's not right in their estimation, and so they assume that it escaped from the rocks. Well, if it's not in the rocks, it ought to be in the atmosphere. Well, it's not there either. And we look in the atmosphere and we find that there is 1/10,000th the amount that ought to be there if this has been going on for 4 billion years. Obviously, something's wrong. If you measure how much is there, calculate how long it would take at the present rate to reach the present volume of helium-4, you would come out with just a few thousand years. Some would say that less than 10, and some would say a little more. But it's certainly much closer to the few thousand years than to billions of years called for by the evolutionists. They're so far off, they should just quit. Dr. Patton also says studies of the helium method have shown